Hello everyone, in this video we are going to evaluate infinite series 3 over 2 plus 5 8 plus 7 32 plus it continues in that way. Before we start solving, let us try to check whether it is a geometric infinite series or not. Consider the first term as g1, the second as g2 and the third as g3 and try to check whether the common ratio is the same by dividing g1 over g2 or g3 over g2. Anyways, you can divide any consecutive terms. If you divide 5 over 8 by 3 over 2, that means you will multiply by 2 over 3. So by 2 1, this by 2 4, it will be 5 over 12. Okay, can I take this one as a common ratio? Let us check g3 over g2 also, it should be the same. That means 7 over 32, I have to divide by 5 over 8, that means I will multiply by 8 over 5. So by 8 1, this by 8 4, so I got 5 over 20, I mean 7 over 20. They are not the same. It should give us the same result. And to apply the infinite series formula, the common ratio has to be the same. At the same time, that common ratio r has to be found between 1 and -1. If that condition satisfies, we can apply the geometric infinite series formula, that is g1 over 1 minus r. But this time we cannot apply that, so we need to design some kind of systematic approach. So if you see the denominators, they differ by 4, I mean multiples of 4 each. Look, 2 goes to 8, that means multiplied by 4, and 8 goes to 32, multiplied by 4, and 32 goes to 128, which is multiplied by 4. So we can take the whole series as s. We can say it as s. S is equal to, we can say 3 over 2 plus 5 over 8 plus 7 over 32 plus 9 over 128 plus it continues. So if we multiply both sides by 4, because we said each of the denominators are the multiples of 4. Okay, the denominator, the previous denominator multiplied by 4 will give you the given denominator. So let us multiply both sides by 4, but don't forget the beginning is s. Our objective is to find s. Therefore, when you multiply both sides by 4, the left hand side s multiplied by 4 will be 4s, but the right side 3 over 2, when you multiply by 4, you know, when you multiply by 4 here, by 2 1, this by 2 2, and 2 times 3 will be 6, plus the same manner here, when you multiply by 4 1, this by 4 2 remains, so 5 over 2, and the next 7 over 8 plus 9 over 32, it continues in this pattern. Next step, we can take the difference of the two equation. Now here we can minus from the lower part, or from the second one we can subtract the upper one, because 4s minus s, you know, obviously it's going to be 3s. So let us see after subtraction what we will have. Okay, let's do it. So when you minus it, you know, 4s minus s will be 3s, but the 6 keep it as it is, 6 come as it is, and 5 over 2 minus 3 over 2. Look how to subtract these two. When you take the difference of these two, you know, the bases are the same. From the down, I'm going to subtract the upper part. Okay, so the denominator is the same, so 5 minus 3 will be 2. 2 over 2 means just 1. Here it is. Again, I will continue in that way. So the next one will be 7 over 8 minus 5 over 8. 7 minus 5 will be 2. 2 over 8 means we can simplify and write it 1 over 4, plus again 9 over 32 minus 7 over 32. The denominator the same, so 9 minus 7 will be 2 over 32, which is 1 over 16. It continues in this pattern. Now try to observe what we have here, the remaining part. This is a geometric sequence or infinite series. If you see the difference, I mean the common ratio, 1 over 4 divided by 1 will be 1 over 4. Again, 1 over 16 if you divide by 1 over 4 will be 1 over, because 1 over 16 over 1/4 means it is the same as 1 over 16 multiplied with 4 over 1. So by 4 1 this by 4 4, so the common ratio will be 1/4. So we have common ratio which is 1/4. It can satisfy the condition to apply infinite series formula, that is r must be between 1 and -1, and at the same time the g1 will be, it's 1. So we can apply the formula for this one, g1 over 1 minus r, and we can find the sum of this infinite series and then substitute. Therefore the geometric infinite series, as you see here, which is enclosed by the green one, this is infinite series. It has first term g1 which is 1, the first term is g1, and the common ratio when you divide, it's going to be 1/4. Then the common ratio satisfies to apply sum at infinity rule. The sum at infinity will be g1 over 1 minus r, that is g1 is 1 over 1 minus the r is 1/4. When you take the difference, you can apply crisscross. 1 times 4 4 minus 1 times 1, it's 1, so it will be 3/4. So 1/, it will be it's going to be flipped and it will be 4/3. Therefore let us try to finalize now. 3s is equal to 3 plus 6 plus 4/3. Again, here we can apply crisscross and we can do it. 18 plus 4/3, which is 22/3. This is 3s. Now we can multiply both sides by 1/3 to cancel the 3 here, because our objective is to get s. We already said it, s is equal to our original sum. So when you multiply by 1/3 both sides, this side by 1/3 and the other side also 1/3, the objective is to cancel the 3 here. Then the s will be 22/9. This is the infinite series that we are trying to get. It is its sum. So the sum of this infinite series will be 22/9. Thank you for watching. Don't forget to like and comment.